Okay, so welcome back to another video. So here we have a limit that we want to evaluate. So the following limit given is the limit as x approaches infinity of, so in the expression contained is the fourth root of x minus p times x minus q times x minus r times x minus s, and then outside of that radical is subtract x. And of course, this is where P, Q, R, and S are real constants. So typically, when you see limits and then we have radicals, your first intuition in solving is probably multiply its conjugate, which actually, yes, that's actually the correct first step on how to evaluate this limit. So this is typical doing stuff with like stuff you learn in Calculus 1, especially if you know that if you were to take limits as x approaches infinity at this standard form, to where it might give you some sort of, it's likely to give you some sort of indeterminate form, but we want to, fix that up so that we don't actually end up with like an indeterminate form. And so there's actually a lot going on with this, especially we're dealing with 4 different variables. Well, they're all 4 of them being real constants, but there's actually a lot of, not really a lot of steps going on. Instead the video for this is actually short, but rather there's actually a lot of writing in solving this limit as well when you're writing each step. So I have nothing else to add. I just gave you away the first step on how to solve this limit. So let's figure out the rest and jump in. So as mentioned, we're going to multiply its conjugate. There's going to be a lot to write here, so instead of starting where I usually write on the left side, I want to utilize all the room I can whenever there's a lot of stuff we need to, put down. So I'll start from over here and work our way down. If I need to, then I'll move to the left side from here. So here, if we're given for our limit, and then we're going to multiply the conjugate. So this means in replace for negative x, this will be multiplied with positive x of that same expression. So now here we're going to have the fourth root of this of x minus p, then x minus q, x minus r, then x minus s. Subtract x. All right. Then we're going to multiply by the conjugate. So this is the same expression again for x minus p, x minus q, x minus r, x minus s, and then now this will be plus x. And then from here, just multiplying its conjugate, so that means we have to divide that as well. This is also the same standard way of saying multiply and divide, utilizing to get that is equal to 1. So that means below our denominator is basically just going to be the conjugate that we just multiplied with. So again, same thing, fourth root, x minus p, x minus q, x minus r, then x minus s, then add this with x. So now if we actually just write this out, then clearly you'll see that the numerator is basically in a form of a difference of squares. So really the only thing we have left in the numerator is just the square root. Yeah, we have the square root. Since the fourth root, it's if you're multiplying these together, just like you're adding exponents, so this will become a square root, so 2 in this case. So x minus p, x minus q, x minus r, and then x minus s. And now multiply this with your minus x times x, so that'll be minus x squared. Okay, and then the denominator is still the same with the conjugate below. So I'm gonna just cut that out and just move on to the next step after writing. All right, so now the next part is, now what do we do from here? We're still dealing with radicals. Again, you can actually do the same thing, just multiply the conjugate. Really, the conjugate we want to multiply specifically is the one from the numerator. So here, let me just write out the first part, and then I'll leave out and write the conjugate. And then now over here is we want to multiply its conjugate. So now this time this is multiplied with plus x squared over here. So we're just rewriting the same thing again for the radical expression. X minus p, x minus q, x minus r, then x minus s. Add this with x squared. Now from here, that means we have to multiply its conjugate from the denominator as well. So here I'm just going to write the same thing for the fourth root. So the fourth root, x minus p, x minus r, x minus, or this is supposed to be x minus q, then r. Sometimes it's hard to get the order mixed up sometimes. So x minus r. Then we just multiply by the conjugate from over here. So same thing, x minus p, x minus q, x minus r, and then x minus s. Add this with the x squared. Okay, just send this line out. Okay, so now from the numerator, we can just do the same thing again, just multiply. This is actually still in a form of a difference of squares. Okay, so obviously we just see that all we're left with is just the square roots will cancel, and then we just subtract a x minus 4. But, well, not really a but I like to just write this neatly as I can so that the numerator looks center. So really, the denominator is still going to remain the same for now. So actually, this is supposed to be a 4 right here. Yeah, little 4. Okay. So this is supposed to be the fourth root down below. I'm just gonna write the value for the expression for the denominator first before I put in the numerator, for the sake of just making things look nice and orderly. Now, as mentioned, the difference of squares. So now the numerator, it's going to look like as x minus p, then x minus q, x minus r, and then x minus s. Subtract x to the power 4. We actually want to expand out the numerator, so this part's actually going to be really, really long, and I'm not going to show all the entire work. I'm just going to give out like what the expansion is supposed to come down to. Okay, so here's what I'm going to do. Just to save the room, what I'm going to do is I'm just going to note note the quotation marks. What I mean when I say that is that because there's a lot to write for one. So the quotation marks where I denote it under the denominator, that's going to remain the same thing from the denominator over here. So this is just saying the denominator is unchanged. This is the same thing to the next line right here. I'm just saving room for work, just so like I don't have nothing gets too complicated or I lose track of what I'm doing. But if we do the expansion over here, so we're gonna have this is x to the power 4. Add this, or rather subtract. And then if you actually do a little bit factoring, cleaning up with the variables and coincide with that, we have p plus q plus r plus s multiplied by x cubed, pq plus pr plus ps plus qr plus qs plus rs, then multiplied by x squared. There's still more room to go, so I'm just going to extend this out. So this is a continuation of the next line. So x squared, and then subtract with pqr plus prs plus pqs plus qrs x. Then add this with pqrs, and then now subtract with x to the power 4. And then denominator is still the same from below, so just to note that in quotations, this is still the same thing from over here. So here's the interesting part here. So even if you were to take the limit as x approaches infinity, you're still going to get that this is like a indeterminate form of an infinity over infinity, that you can, if you want to, apply L'Hopital's rule, but I think doing that is just going to make things even more complicated and out of control. So let's actually do a little bit something simpler. So what I'll do here is notice that, of course, the x to the power 4 cancels each other out. So this is gone, and then this is gone. So that's nice. We have a little bit of room to work here that makes things a little bit easier for us. Now what I'll do is that I'll divide an x cubed from the entire numerator. So now the expression on the numerator is going to look like this. So we have a negative, then a p plus q plus r plus s. Then we're going to add this with, so divide by x, that will be x on the denominator. So here this is pq plus pr plus ps plus qr plus qs plus rs. And then that's all being divided by x over here. Then the next term we have, so divide that by x cubed, so x squared is on the denominator, so we have PQR plus PRS plus PQS plus QRS, and then divided by x squared. Then down below, the next term is PQRS divided by x cubed. Okay, so that's just the numerator over here. So now we want to evaluate the denominator. There's actually a way to do this easier, because even if you were to take the limit as x approaches infinity from the denominator, everything will still become infinity. So we're going to make things a little bit interesting and manipulate it this way. So what I'm going to do, and I'm going to explain this after I write all this down. So here, this is going to be the fourth root. Then down below, this is 1 minus p divided by x multiplied by 1 minus q divided by x multiplied by 1 minus r divided by x multiplied by 1 minus s divided by x, and then add this with 1. Now do this, and now for this term right here, I'm just rewriting. So this is going to be the square root of 1 minus p over x times 1 minus q over x times 1 minus r over x, then times 1 minus s over x, and then we're going to add this with 1. So what you'll notice is, how do we get from these two terms to all the way here? Well, what you can do, so we'll start off with this left term over here. So we can actually expand this out, and expanding this out, we're going to get the same thing just from this right side over here. That's the same thing, but just if you're excluding the square root function, or the fourth root function, and the minus x to the fourth. So just expand that out. You can factor this out to rearrange it in a term here, but I factor out the x to the power fourth from all this product, take the fourth root out of that, so now actually outside of the fourth root will be an x multiplied by that. Divide x to everything, so there it used to be an x here, so now that's why with that division we have that it's 1. And now from over here, you just apply the same thing, expand this out, but instead, since it's the square root, so now outside of the square root, it's just an x squared multiplied by here, divided by the x squared to everything down below, and we'll just left up with the following expansion over here. So now the final part is very simple. Now we just take its limit as x approaches infinity. So over here, take infinity, this is going to be 0, that's going to be 0, that's going to be 0. The only thing left with is the numerator is that this is just minus p plus q plus r plus s. Okay, but now let's take a look at the bottom. So over here, 0, 0, 0, 0, so this is 1 times 1 times 1 times 1, so that's 1, and then fourth root of 1 is just 1. Add this with 1, so this is going to be 2. Then same thing over here, 0, 0, 0, 0, 0, so this is 1 times 1 times 1 times 1 is 1, then square root of that is just 1, plus 1 is 2, multiply the 2 together, 2 times 2 is 4, and there we have it, the final answer of our limit, like so. Underline, or rather, box in the blue. Yeah, there's just a lot of writing going on, but actually the method is simple as you think. So our limit, and this is the final answer of a closed form that we have just found with the following real constants. So yeah, that's pretty cool if you ask me.